Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Suppose we want to measure the effect of education on income. Normally, you would run a regression that looks like y equals to beta 0 plus beta 1, and we would have here education plus error term. You get a positive coefficient, so normally you would include education increases income. But is that coefficient actually measuring what you think it is? We have quite extensively talked a little bit about this when we introduced the Frisch-Lovell theorem and how we can exactly take the pure effect of a particular x on our y variable. In this video, we're going to introduce to you omitted variable bias when missing a variable distorts everything. So based on the question that we just posed in here, will this beta 1 measure exactly what we want it to be measured? The follow-up question that normally comes is, well, what if something else also affects income, but it's also related to education? And you can think of many such cases. You can think about ability. You can think about motivation. You can think about family background. These are all variables that can affect y, which means that if we don't include them in this regression of ours, they are inside of our error term in here. However, look also at the fact that some of these variables, or all of them, actually can be correlated with the actual variable of education, okay? So any of these variables in general can be driving our results that we're seeing, but at the same time, they could be also driving the results in an unpredicted way for us. Because think of, for instance, of ability. More able people get more education and also earn more. More motivated people study harder and work harder, which means that not only are would they be affecting the regression for y, but they are also diverting the effect of education because they are all also correlated with education. But none of these variables have been included in this regression. So what are we actually measuring with beta 1? Because what that means is that we are estimating a misspecified model, which means that you might think you're measuring beta 1 as you should, but actually you are not. Because education and ability are correlated, your education, beta 1 in here, is doing actually two jobs at once. So when such variables are missing, and when I say such variables, meaning they're also correlated with education. What's happening in here is, one, the beta 1 is capturing the effect of education on income, and at the same time, it's also capturing the effect of ability on income, okay? So the coefficient is picking up both effects simultaneously. It is no longer a clean measure of either of the two effects. And this is exactly the contamination problem from the regression anatomy. And we have failed to clean it, okay? So contamination problem from a regression anatomy, okay? When a relevant variable is omitted and it is correlated with an included variable, the estimated coefficient is biased. And this is exactly omitted variable bias, which most of the times you're going to see me using the abbreviation OVB, but what means in here, what is happening in here, or what this bias means for us, is that on average, our estimate is not equal to the true beta 1. So we are systematically getting the wrong answer. Okay, we are not just being imprecise, we are literally giving the wrong beta 1 hat estimation in here. And that's why omitted variable bias is a very serious problem to be taken into consideration. Now, what's the intuition behind this like contamination? If you think back to the regression anatomy, when we include ability, regression removes its influence from both education and income. So if we move from our initial model of y being equal to beta 0 plus beta 1 education plus u to y equals to beta 0 plus beta 1 education plus beta 2 ability, and then error term. So this is how, by controlling it, we're managing to get rid of the influence that ability was having on education, and that then was being reflected in this beta 1. And in that case, using the Frisch-Wallow theorem, we can say that what's left is the pure relationship between now education and income. But when we omit, so when we actually don't include ability in this regression, so if we're back to this first one, we never clean education, the contamination stays, and the beta 1 hat is basically picking all of that up. The Frisch-Wallow theory matters a lot. Like, especially now seeing it in context with the omitted variable bias, we can say that the Frisch-Wallow showed that beta 1 comes from partialing out all the other variables, and the OVB shows us what happens when we fail to do that. So these are, in a sense, two sides of the same coin, because the Frisch-Wallow is saying what regression does when you include the right variables, while OVB is literally telling you what goes wrong when you don't. So keep that connection in mind, because it will make everything that follows in here a lot more clearer. So when does OVB occur? And this is one of the places where students make the most mistakes, especially in exams. A lot of exams at the introductory level usually will have questions like, we have omitted this variable. Can you tell us whether this regression is still going to be okay or not? And the part where the students make a mistake is that they forget to write the two conditions that must hold for OVB to occur. So OVB occurs. So you keep in mind, you have to write both conditions. When the first condition, which is the one that all of the students get right, the omitted variable affects y. So in questions where they ask what could have gone wrong with this regression, students very easily tend to figure out one or two variables that are in the error term that should have been included because they would have made the model better. However, what they forget, which is the most important part, and this is what causes the actual OVB, is that the omitted variable is correlated with x. So If you give me only this direction in an exam, but you don't give the second one, then you have only answered half part of the OVB question, because both of these need to be fulfilled. Both of them are necessary for you to actually be able to observe omitted variable bias. Okay? If the omitted variable is uncorrelated with the X, then there is no bias in here. Okay? And this might surprise a lot of students, but if you think about it, and especially now that you have seen both visually the Frisch-Waldo-Well theorem, you should know that if the omitted variable is unrelated to X, it means it cannot contaminate X. It just goes into the error term, which is fine. It just means I haven't found all of the variables that are affecting my Y, but so what? The effect of that one particular variable that I need has not been contaminated. Okay? And this is also why randomized experiments work, because a random assignment measures X is uncorrelated with everything else, included omitted variables. Omitted variable bias occurs once again when a missing variable both affects the Y and is correlated with an included regressor, causing our estimate to be systematically wrong. In the next video, we're going to derive the OVB formula and see exactly how large the bias is and which direction it goes. So stay tuned and I'll see you then.